Hey, geometry students, welcome back. I would like you to make sure before you start today with your notes that you check the due dates for your assignments on each day you're back on campus. Those assignments that I expect to collect are in red, so they're listed. Check what's going on for the AB, your AB days and what day you're going to be on campus. Those are the assignments I'm going to expect you to have. Okay, well, let's get to notes. Geometry, notes 1, 2. Okay, geometry is a mathematical system built on accepted facts, basic terms, and definitions. Undefined terms are the basic ideas that you use to build definitions of all other figures in geometry. So if you haven't already guessed it by reading our objective, to understand basic terms and postulates of geometry is what we're doing today. So it's really a lot of definitions, a lot of things that you're going to have to reread and check out. We've got defined terms and their descriptions. The term description, a point indicates a location and has no size. So to name it, a point is represented by a dot and is named with a capital letter. Hey, I think you might have to make a correction on your notes here. Okay, but look at this point. It has no size, but it has a capital letter as its name. And it's very structured. It's got to be a capital letter. Okay, the next term we have is a line. A line is represented by a straight path that extends in opposite directions without end and has no thickness. Okay, a line contains infinitely many points. Now, whenever someone says measure the line, it's not really a line they're measuring because a line has an infinite length. Okay, if you're measuring it, it's a segment. So keep that in mind as we're going through. Now we have a representation of a line here, and we're going to talk about how it's named. A line is named by any 2 points, capital letters, again, because those points, capital A, capital B, represents the 2 points on the line, and we can use them to help us name it. But to be more specific, we'll use a symbol that represents, hey, a line on top of that. So look at this, a capital letter on the line. Example, line AB, or we could say it's line BA, or by a single lowercase script letter, like this one here. This is an L, it's not an E. The letter example is line L. So keep in mind, this is a lot of basic notation you are expected to know how to use when you're reading tests, reading assignments, and just, going through notes. Our next term that we're working with is a plane. Now, it's not something that carries people from one point to another. A plane is represented by a flat surface that extends without end and has no thickness. A plane contains infinitely many lines. Okay? So remember, this is a representation of a plane. We can use 3 letters. Yeah, let me click on this. Plane is named using a capital letter such as plane P. This is plane P, a capital letter without any symbols around it. Or by at least 3 points. Did you see that? At least 3. Could be 4, but at least 3 points in the plane that do not all lie on the same line. Okay, so they have to be non-collinear. Okay, they are not collinear. Okay, such as plane ABC. So plane ABC, or just plane P. Okay, notice ABC are represented as points, and plane P is just the name of the plane. Now, collinear points are points that lie on the same line. Coplanar points are points that lie on the same plane. Coplanar lines are, what do you think? Lines that lie on the same plane. And a lot of people get confused with this thing. When you have a co-worker, that worker works at the same place you do. So when you have collinear points, they're points on the same line. Coplanar points, they're points on the same plane. And coplanar lines are lines on the same plane. Now, what two other ways to name line QT? Now, please look at the figure. I've got line QT right here. Now, Q is the intersection point of the line with the plane, and it's also a place where the two lines that are on this diagram intersect. This line is represented as going through the plane. So line QT, or you could say line M, or line NQ, or line NT, is the same line. It goes through the plane because of this dotted section. They're trying to represent it as a three-dimensional figure for you as you're going through. So make sure you're careful about looking at diagrams. Kind of read all the stuff. Physically touch the diagram. We got on a line that is contained in the plane. Please notice there are no dotted sections on this line. Line RS, or line QS, or we can say line L, is contained inside plane P. Okay, so know these things as we're going through, but now let's answer our question. What are the two other ways to name line QT? Line QT is also named by line NQ, line NT. We could even say line TQ. Also, using M, we can use line M. And I didn't put that in there, and I did mention that. Okay, what are two other ways to name plane P? Now remember, this is the plane name, and all we need is 3 points that are not on the same line. So I cannot name this plane as plane RQS because these are points on the same line. But I could name it plane RVQ, or plane QVS, or plane SVR, any one of those, but I just put up 2. Okay. Now, let's get rid of that. What are the names of 3 collinear points? Now, 3 collinear points. Collinear are 3 points that are on the same line. Collinear. R, Q, S are collinear. T, Q, N are also collinear. But I just wanted one set. So T, Q, N is good, or R, Q, S is just as good. What are the names of 4 coplanar points? 4 points that are on the same plane. P isn't included as a point because it does not have that dot representation of the point. So we have R, Q, S, and V as 4 coplanar points. Okay. Now, in this next section, what are 2 other ways to name line RS? So we got line RS, we could say line SR, line SQ, line QR, line QS, line RQ, or line L for that matter. I just wanted 2 more. What are 2 more ways to name plane P? Now remember, plane P. 2 more ways, and what I want you to do is look at how we've done it. We have, what are 2 other ways to name plane P? RQV, QSV. What are 2 more? Plane RSV and plane VRQ. Now, what are the names of 3 other collinear points? Now, we had names of collinear points, TQN, 3 others, RQS or SQR. In D, what are the 2 points that are not coplanar with points RSV? RSV. What are 2 points that are not coplanar with points RSV? Now keep in mind, they cannot be in the same plane. So RSV are points that helped us name a plane, plane P, and they reside in plane P. So I just want 2 other points that aren't in the plane. And in this diagram, the 2 other points that aren't in the plane is point T and point N. Now we have a few other geometric shapes that we're going to work with. The definition: a segment is part of a line that consists of 2 endpoints and all points between them. A segment is named by its 2 endpoints. Example, A and B are endpoints. They are points here as we go through. So it could be segment AB or segment BA. Notice we have a picture of the segment on top of each. This is helping us identify and name our geometric shape. In this case, we're talking about a segment AB. Our next one, we're looking at a ray, is a part of a line that consists of 1 endpoint and all the points of the line on one side of the point. So this is an endpoint, and all the parts of the line on one side. Now, keep in mind, if I had this as a full line, it would have continued over there. I know, it's a beautiful line I just made. But if I had it, and I had point C here, I would be saying ray AB doesn't include this part. But ray AC would, because I start with an endpoint and it has a direction to go through and it continues on in the direction of C away from point B. So keep in mind as we're talking about these things what that visually looks like as you do it, because if you can visualize it better like that, it'll actually make it easier for you to recall what a ray is. Okay? A ray is named by its endpoint and another point on the ray, such as ray AB, red ray AB. The order of points indicates the ray's direction. This point, this first one, is always the one that's the point that is the terminating point, or they'll talk about an end point. Okay, so keep that in mind as we're going through here. Now, opposite rays are two rays that share the same endpoint and form a line. So I've got opposite rays CA and CB. I'm going to pull that away here. I got opposite rays CA and CB. Opposite rays are named by their shared endpoint and any other point on each ray, such as ray CA. So I got ray CA. And ray CA, although I write it from left to right the way it is represented, look at where ray CA is going. It's going that way. And ray CB, a completely different ray from CA, is going that way. And these two rays will combine to make a line because they are opposite rays, and that's the definition of opposite rays. Now, what are the names of the segments in the figure at the right? Now, keep in mind we're talking about this figure and we're talking about their segments here. Okay, so segments have two endpoints, one at the beginning, one at the end. I have segment DE, segment DF, segment EF. But I also could name them segment ED, segment FD, okay, segment FE. So I have these, and please notice you must use the little symbol above the two letters, the capital letters representing the endpoints of our segment, in order to name the segment correctly. Now, what are the names of the rays in the figures? Well, they're pretty much the same names, except now I'm going to be talking about rays in the direction, because I could go ray ED and ray EF and ray DF and ray FD. Okay, so I got ray DE, I've got ray DF, I got ray EF, I got ray FE, and I got ray FD, and I got ray ED. Okay, so keep in mind how many times and ways I can do these things. Which of the rays in part B are opposite rays? So I'm really looking for two rays that have the same terminal or starting point. Okay, EF and ED, EF and ED are opposite rays, and those are the only opposite rays I have, because they have the same point, they share a common point and nothing else, and they go opposite directions to make a line. Ray EF and ray FE form a line. Ray EF and ray FE form a line, because ray EF does this. Please, if you're doubting something, if you're not sure, just draw it in, check it out. And ray FD goes this way. Look at that overlapping space. Okay, because of this overlapping space, they're not considered opposite rays. No, they are not opposite rays. They share more than just an endpoint. So keep that in mind when you're working with your definitions. Now, postulates and axioms are accepted statements of fact. And postulate, this is like low and high. They're considered the same thing. We will use the term postulates the rest of the semester. But axiom is what it is. Okay, we're on page 4 of 5. Okay, postulate 1-1. Through any 2 points, there are exactly one line. Line T passes through points A and B, and line T is the only line that passes through both points. Okay, there's no other 2 points to find a line. We can give an example of this. Plotting lines on a graph. You need 2 points to draw a line. We always find a third just to make sure that we didn't make a mistake on the first 2. Okay, now we've got intersection. Is the set of points the figures have in common. So I have an intersection of these 2 lines, and that's just this point. Okay, so let's look at what intersection and how we'll use it with postulate 1-2. If two distinct lines intersect, two distinct lines here, line AE and line DB intersect, then they intersect in exactly one point. Well, this point is the point of intersect. So if they intersect, they'll intersect exactly one point. So line AE and line DB intersect in point C. That's what this postulate's stating. So we'll give it an example, the solution of a system of equations, a place where the two lines have the same value. Now in postulate 1.3, if two distinct planes intersect, then they intersect in exactly one line. So I've got two planes intersecting here, and we've got plane blue and the yellow plane. And we have this point of intersection here. It's like an axis of where they're intersecting. Plane RST, and plane WST intersect at ST. Give an example of when postulate 1.3 of this happens. When a wall and ceiling intersect, I've got two planes intersecting, and they'll make a line. Now, each surface of the box at the right represents part of a plane. What is the intersection of plane ADC, and the plane BFG? Well, let's clean this box up a little bit. If I've got ADC is this box. And let's change colors. And if I got BFG is this box. 3 points to find the plane. Check it out, the intersection right here, BC. Okay, so I'm going to go over my clicker, click on it, and go, the planes intersect at line BC. Okay, now please recognize that this box is representing space. Okay, so when I say they're intersecting on a plane, and I've got some students going, oh, you know, Bloom, that looks like it's a segment. You got to consider the fact that this box keeps expanding and going without bound forever. They have the intersection, but they keep going. So this is really line BC. Okay, if I have these sides of the box, and there's 6 sides representing a plane, those sides keep expanding forever. That way we have an idea of what it's going to look. We have depth in our picture and see what's going on with it. What are the names of two planes that intersect at BF? So let's check out BF. So line BF are right here. So the planes that intersect at BF are ABF and CBF, or AEF and CBF, or, you know, there's a couple ways I can name them, but do you see that's this front plane and this side plane here, they intersect here at line BF. Oh, I'm answering the questions, plane ABF and plane CBF. Now, why do you only need to find 2 common points to name the intersection of 2 distinct planes? Well, planes, when they intersect at a line, and 2 points define a line. So postulate 1.3 says 2 distinct planes intersect in exactly one line. So you only need 2 points to name the line of the intersection. That's by postulate 1.1. Now, I ask this every year, and I ask students to raise their hand. So doing this on video is going to be kind of tough because I can't figure out if you're raising your hand or not. But I'm not sure if people have seen a milking stool, or if you have a grandfather that milks. It's a 3-legged stool. So we'll use a tripod here this year. We have a tripod, a camera being held by a tripod here. And the reason we have a tripod is that at any 3 points define a plane. All the time, so long as they're non-collinear. So that means it is a very stable surface for the tripod to stand, and then we can adjust our camera as we need. So through any 3 points, non-collinear points, there exists one plane. Okay. Points Q, R, and S are non-collinear. Plane P is the only plane that contains them. So when farmers had a 3-legged stool to milk their cows, they could put the stool down and it would be a very stable surface. It might have been crooked, but it would have been stable because all 3 legs are in the same plane. If you took a chair at home, or a table that has 4 legs, or even your desk at school, and you were able to rock your desk, it would rock, and then it'd stop rocking when there are 3 legs in contact with the plane. And you could shift your weight and it'd rock back and it'd stop rocking when 3 points or 3 legs are exist in the same plane. So that's where this idea of 3 points defining a plane exists. So I just gave you a couple examples, but tripods are very steady because the 3 legs touch the ground in the same plane. Now we've got a few other examples, some sketching examples here. What plane contains points N, P, and Q? Shade the plane. Well, N, P, and Q is right here. This is my shaded plane. So I just find the 3 points and I try to make it happen. Well, let's get a pen here, get a blue one here. What plane contains J, Q, and M? Well, weird, but check this plane out. It's J, Q, and M. Think about this as a ramp going up that way. Okay, so it's kind of going through there, and I think I've got it set as we go through. So what plane contains points L, M, and N? So I got L. Where's my L? I think this is L. L, M, and N. Sorry guys, I just kind of screwed that one up. You see this ramp coming and going through here? See if we got that. That is going back out through here. Okay, L, M, and N. Now, what plane contains points J, N, and Q? J, N, and Q. Well, check it out. It's this diagonal coming through here. So those are the 3. 3 points define the plane. Once I know 3 points, I can get the rest of it all drawn out. Now, what's the name of a line that is coplanar with line JK and line KL? So they're saying line JK and line KL are in the same plane as another line. So let's look at this. Line JK, line KL. Okay, so couldn't I say, hey, look, line ML is in there, line JM are in there, so those are possibilities, and the reversing them is a possibility. And I could even look at diagonals. I put in diagonals here. The diagonals going through here and through here, they'd be in the same plane. And those were not very good, so let's try that again. Those are the originals. Let me get a better representation of lines that we can work with. So I was talking about, whoa, that's a little big too. We want to go there. And I want arrows on the end. Okay, there we go. And we're going to go red with this. So now, let me go back here. And let's see if we can do that again if we have all those selections done correctly. And we're red. So now I could go here, that, and I could go to diagonals and my other diagonals. So those coming through, and just to clean those up, this one as well. Okay, so those diagonals are also coplanar with those other ones that we started with. Okay, now use the figure at right and see what you can do about coming up with what it is. What are the 2 other names for line XY? I've got line XY. Come up with 2 other names. This is our review. Did you come up with line XR and line RY? What are the opposite rays? Opposite rays. Now, I could say that this is an opposite ray with this, but there's no letter over here, so I've got 2 letters on either side of R. So I've got ray RX and ray RY are opposite rays. What is the intersection of the 2 planes? The intersection is 2 planes is always a line, so I got line RS or line SR. Okay? And that's notes for today, folks.